Okay, my name's Bruce, this is Krista. I'm a product manager in the desktop team in Redlands, and Krista is a product engineer actually based out in Virginia. Is that right?
Yep.
And if you ever wondered who writes the beautiful documentation you read when you research geocoding capabilities, this is the lady here. So now you've met her. Okay, so today's presentation is early in the week because it is just an introduction to capabilities that you can research further through the rest of the week. And part of this presentation is a slide showing all the other sessions which are on Tuesday, Wednesday, Thursday. And of course in the showcase area, most of the Geocode team, all the brains trust, they're available. So you go away with ideas and questions that we don't answer here. Do hammer them downstairs in the showcase area and go to the sessions during the week. So I've got to do a couple of demos, so I'll be up and down like this a little bit, but we'll start off with the agenda. So I'll just sit down right now, why not? So it's been a long day for us too. So here's the kind of running order, with a little bit of intro about what is geocoding. Then we'll go through who's using it and what for and how in terms of business cases. And then we'll have a look at geocoding capabilities as the technology that supplies the goodness in those business cases. Then we'll go through how we are productizing, shipping that goodness to you, not just online on the web, but in actually shipping products that you can install on your own premises. Then once you've decided which products are your best fit for what you're going to be doing, we'll cover the deployment patterns that you use to put those things into practice in apps and in your workflows. A couple of demonstrations to break it up, and then we'll start winding down with some discussion on what's new in our products and services, and finish with a summary of what you've seen and heard. And of course, we'll hope to leave like 10 or 15 minutes for questions. So, I mentioned that there's a whole lot you can see during the week. Here's the starring features going by there. Those are the topics and sessions that you can have a look at and go to during the week. And again, we'll put the slide up later on in the presentation so you can make a note or take a picture. Okay, so what is the magic of geocoding? And I've always enjoyed working in this area because I find it just fascinating. You can take some kind of description and turn it into a coordinate. It's full of challenges and it's full of value. So typically you'd be thinking of geocoding as handling a street address. You're not limited to that at all with what we ship and what you can do yourselves. You can take a place name, a business name, a point of interest name, and the engine underneath all of this will understand that and interpret that into a coordinate, just the same as a street address. Of course, once you've got them onto the map, that's where your value-add life experience begins, or the new life you give your data kicks off. So again, geocoding is just interpreting location descriptions like street address or place or business name as coordinates on the map. But wait, there's more. So with the same functionality or capabilities under the covers there, we'll go through three of the major ways that this functionality is expressed in our products and the apps that you build. Firstly, you'll be familiar probably of, say, the way you find directions in your car. As long as you're not talking to it, you're typing it in, or on your phone, or in a web browser looking for something to go to, then you'll be familiar with the experience of you getting suggestions back as you type. Kind of like type ahead when you're looking up in a database. Same idea, different thing under the covers. But everybody these days expects that experience from a geocode or place search input to these interactive web apps. So we do deliver that. That's out of the box. It's a native capability of our world geocoding. Now, on the top right there, batch geocoding, that, if you like, is the money shot for organizations. They have address and asset location databases full of possibly large tables of address information. They need to turn that into coordinates and dots on the map and feature classes so they can perform analyses, enrichment, and other value-add behaviors. So that's batch geocoding, taking many records at a time and turning them into points on the map and rows and feature classes. And the third one is turning those two experiences around the other way and starting with coordinates and returning human-readable address locations and descriptions that you can give to, say, field crews to go to. That's reverse geocoding, and there's experience there I've copied from ArcGIS Pro. If you right-click on the map, you choose what's next, you'll get a series of candidates, the best in reducing, going down the list, showing you what is the street address at that location. There is a geoprocessing tool that returns the same information as well. So In these situations, there's not just an interactive experience in our products, but there's maybe a geoprocessing tool that does the same thing, and certainly a programmatic access to it through our various APIs. Okay, so those three legs to the stool. Now, Krista might speak to the value add chain here that which you're expressing in this graphic.
Okay, so when we're talking about geocoding, we're talking about it in terms of unlocking value in your data. Value might be in terms of risk, time, money, or energy, and once data is geocoded, it's possible to get that value out of your data. First, just simply viewing your data on a map can reveal patterns and suggest next steps. Like geocoding, enrichment is available globally to bring further context to your data. Classic scenarios of market segmentation of customers. Analytics can be brought to bear too, with examples including density mapping or routing. And data becomes knowledge when you understand your data. So ArcGIS World Geocoding unlocks this potential, whatever segment of industry you work in.
Yeah, I'm not sure that the pyramid is the best graphic to have in this case, because you might say bypass an enrichment step if that's wasn't what you needed to do. But certainly the value chain becomes apparent as you go up, and you can add and add and add these layers to your data. So what are the use cases?
So here are some industry use cases for geocoding, and we'll just talk through some of these. What's shared amongst these four examples is some form of contract, formal or not, tied to location by description. So first here we have insurance. Insured property is described by address or site, and insurers map exposure to risk using environmental data. It's one use case. Retail, in terms of retail, shoppers live and commute between locations. Retailers build outlets at convenient locations for target markets. In terms of logistics, goods and services are moved from and to locations described by address, frequently between countries. And in terms of finance, money is lent, spent, or stolen at locations tied to addresses. For example, banks locate branches where people work.
And a little bit more, while this is up on the screen, our geocoding results that you get back, the points on the map, come back in actually two varieties. The default is the routing location. So that's the you have arrived point that your car will go to if it's self-driving, or the courier will go to if they're delivering something. So the logistics experts want to go to the curbside outside the entrance point of a house or a business. The other coordinate that is supplied by our engine is the you, not the you have arrived, but the on top of the premise point. So it's the rooftop point of the data or the address. So that might be more of interest if somebody is trying to assess roof footprints for taxation purposes. So you're either going to the logistics XY location or the rooftop XY location. So how do we do it?
So in terms of data, geocoding finds coordinates using reference data, and Esri curates the best data available. So it's a global effort involving Esri's network of international distributors, addressing authorities in many countries, and commercial providers whose business is logistics. So what are we looking at with these three circles? In any country, Esri may take advantage of multiple data sources. For example, a mapping agency may supply rooftop address points, and a vehicle routing vendor may supply street-based data needed to find intersections. To be used for our geocoding purposes, data must be authoritative, complete, and fit for business purposes. So national mapping agencies, government agencies, postal authorities are all examples of some of our data contributors. And underpinning all of that reference data is licensed commercial street data from here, whose business it is to support vehicle navigation worldwide. So using this approach, we're building and delivering world-class geocoding for the entire planet with continuous improvement. So in different countries all over the world, we may have one or some combination of these or all three, depending on what's available and what's the best available resource for our users.
And just to demystify those all the acronyms off on the right, there are a couple of mapping agencies in Europe and the National Address File Agency in Australia. So there's a number of these vendors that supply us who put it all together and do the best of breed thing with the set of data.
So to take that a little further, while Esri has global coverage, the work of building out the highest quality locations continues. And if you are the or an authoritative source of point level location data, we want to hear from you. The bar is high. All data will have a rule run over it for conformance with our quality requirements. And if accepted, this data would help power geocoding in your area with Esri's high performance and high availability systems.
And if it's not apparent there from the narration there, what we're looking for is point data. So that would be rooftop data ideally, entrances and businesses, including multiple entrances to campuses, and as a fallback, maybe parcel centroids would be better than we have in a particular geography. So if you own and curate that data, or you generate it, then we're really interested in hearing from you. There's a link on the slide here that goes to a website where you can basically get in touch with us and tell us what you got, and we'll talk back to you. We can go through that as part of the Q&A later in the presentation.
So in terms of geocoding coverage by our World Geocoding Service, we have coverage for 135 countries at street level, but over 250 countries worldwide, with 400 plus language locality combinations over the globe. Esri World Geocoding's country average includes approximately 90% of the world population. The countries here in darker brown represent countries where our geocoding is the most accurate and mature, meaning we have the best quality matches there. But even where street level data is not available, we support place name and POI locations globally. So all countries' data is combined in a single user experience for app users and app developers. So there's no need to specify by country. It's all combined into a single user experience if you've got global address data or one country.
We had a question when we gave this presentation earlier today. So what do we mean by street level geocoding in the first bullet point there? What we might mean by that is when we have an address that either resolves to the rooftop or logistics point for a house or a business, that's street level. So it's generated from point data or secondarily from address ranges on street centerline segments. So those are the two classes of geocode match that we call street level, and they're the two highest quality. There are 9 or 10 other grades of geocode return which are not quite as good or maybe as good, say intersections are good too, but when we say street level data, we need those two classes of feature classes reference data to get that quality. Okay, so what's Esri done to put this together globally? And it would be really tempting, and I've experienced this for many years, to enforce a country-centric view of data, like say a US-centric view of data on all this global data and make it all try and fit into the style of addressing that we're used to in this country. We don't do that at ESRI, so we honour the culture as expressed in their addressing standards and postal standards in every country for which we have data. So Danica there lives in the US. She's used to the house number being at the beginning of address, the postcode or zip code being the end of the address, and street name, city, state, zip in that order. Nico in Germany, he's used to something different. So the street type is frequently concatenated to the street name and the house number comes after that, and the postcode's before the city. So however it is done in the countries where we geocode, then that form is honoured in how we deliver the software and how we let people use inputs. So, international addressing, we get to have the app demo. So this is where I'm in Web Map Viewer here, and just in a browser, happens to be Firefox, and I'm signed in here, so if I did anything like batch geocoding, it would know about me. So I just got some addresses here I grabbed at random by reverse geocoding. I'd previously gone to 10 Downing Street, London, just to get me somewhere on the map. Let's go to that place in Brazil. It goes right there. So let's have a look, pick another one. And in a little minute, in a second, I'm going to ask the audience to give me an address that you don't think we can find. And we'll see how we did. There's a lady from Turkey challenged us earlier this morning and it worked just great. So there was a risk that kind of panned out. So here we go, jump around different countries, and I can't read half of these. I certainly don't know where these places are. But all these formats of address, and this one particularly stands out. It's in Beijing, I believe. They just work. So everywhere we're going, the address format and the language is understood and will just happen for you. Now this experience here is GeoSearch. I'm typing in or pasting in really the whole address. I could go character by character, so that's what I'd like to invite you to do now, is if there's anyone who's interested, give us an address and we'll see if we can find it, or business name. Here we go.
Yes.
Yeah.
It's an address in Ireland. Is that okay? I know it's in Ireland.
Sure. Yeah.
The address is White Point House. White Point is one word.
Not looking good so far.
Okay.
Let's keep going.
The city is Cove, spelled C-O-V-H.
Yeah.
In Ireland, or County Cork, Ireland. Well, it's got White
Is that it?
It's finding it looks like a city or a.
It's just a patch of land, really. It's not just a small residential area.
Oh,
Does that look correct?
Yeah, you found it, yeah.
I found
Yeah,
it.
so the streets had no numbers on them. The houses were just named things, you know.
Yes.
In Ireland, recently, they've gone to a grid system, so every house has a coordinate number. That's how they've dealt with not having roads with numbers on them. In fact, that point was solved. Those roads there have no names. They're just roads, and the mailman knows where everybody lives.
People on Geocoding team are chosen for their courage, because weird stuff happens all around the world. Like there are countries where the road names repeat in very short distances, and you can only resolve the address by going for names of cross streets, which is the only thing that changes for miles around. So stuff happens, and you just have to deal with it. And we were very actually proud of what we've achieved here, and within constraints of not being able to deliver hundreds of server farms to do this kind of work, but being able to do it on one machine. It's quite an achievement. So that was a little interlude there where we geocoded a few places in various languages and certainly different geographies. So let's have a look. So, Krista, Esri's products.
Okay, so in terms of our products that use this world geocoding capability, what are they? So for organizations that require global geocoding coverage with ready-to-use cloud-based services, we offer the ArcGIS online world geocoding service, and that's what Bruce was just demoing in the map viewer. And that's available through our different products across the platform in desktop and runtime and so on. For organizations that need global coverage but require on-premise security, we offer the World Geocoder for ArcGIS product, and that's the same capabilities as the World Geocoding service, but it can be hosted on premises. For organizations that need local data, so continent or country or state level geocoding on premise, we have the StreetMap Premium product to meet those needs, and that can also be hosted individually on users' enterprise accounts. And then for organizations that collect and manage their own asset and addressing data, meaning you have records that are not going to exist in our World Geocoding service, so telephone poles or fire hydrants or trees and national park services, we offer capability to build your own locators to support searching against your own data. And then beyond that, you can deploy your own data in any combination with these three Esri products so that your data is searched first with fallback to these Esri products. So the method for that would be to create a composite locator using one of our desktop applications and prioritize your locator and your data first, and then to fall back to this if for some reason your data doesn't find what you're looking for.
So how do you deliver product to your users and to yourselves and your organizations? So we can ship those products to you, like StreetMap Enterprise, StreetMap Premium locators. You can subscribe to our services, but where can they be used? So the first message is that the underlying geocoding engine is the same right across our platform. So desktop, enterprise, runtime SDKs, under the covers, the engine is the same. And the same structures and API calls are used by the layer over the top of the engine. So for Pro, for example, our premier desktop application, you could say it's a heavyweight client. That's where a lot of the analysis work that you do day to day happens. That understands both the file-based form of locators, the locator on disk, and also understands the geocode services. So web apps, of course, depend for all their functionality being back-ended web apps built with the JavaScript API, and the widgets understand any geocode service, not just our ArcGIS Online one, but ones you stand up yourselves. And a hybrid experience can be had in mobile apps written with the runtime SDKs if there is a mobile map package delivered to the device, or the device is connected, then it can understand either or both of file-based and service-based geocoding. So just to pick out each of those three deployable technologies there, starting with desktop. Desktop is where we create locators and where you can too. So you have reference data, you can make a locator, file-based locator, on disk yourselves with ArcGIS Pro, and also, of course, with ArcMap and ArcCatalog. Desktop also creates packages. There's various types of packages that Pro can generate. One is a locator package, which is used for sharing of a whole locator. You put that up on your portal or in ArcGIS Online. And the other one is a mobile map package, which is how you provision mobile apps with geocoding capability that's going to be file-based. Krista mentioned composite locators. Pro is the place where you'd build one of those. So you'd use your data in preference to ours, or several layers of your data together, and say we'll have a fallback situation as we go through each of those classes of locator. And lastly, desktop is able to publish geocode services. So if you publish a service, you can use your data or ours. Say, we were speaking to a gentleman earlier today who was in the health game, and he thought, well, he just needs to work in California. He could get StreetMap Premium just for California, publish services which he can use totally behind his firewall, and then none of the sensitive health data goes out on the public internet. It's all staying in-house. So that's where you would put together those kind of architectures with desktop.
So in terms of geocoding on mobile devices, Esri does have a number of apps that are available for download for different solutions. And then we also have a collection of runtime SDKs with APIs in a lot of different languages for different types of mobile developing and desktop developing. So we have Android and iOS SDKs, for instance, and we have .NET SDKs that would be used for desktop. Primarily the use for the mobile SDKs is for forward and reverse geocoding, like single requests sent as opposed to batch, although the batch capability is supported in like the .NET SDKs if you're creating a desktop application. We do, these apps also, or the apps and the SDKs do also work in online or disconnected environments. So if you're working against the online World Geocoding Service, if your mobile device is connected to a network, you can use that functionality. And we also, through the mobile map packages, support completely offline geocoding in mobile environments, forward and reverse geocoding, suggestions, support, and proximity geocoding, meaning you can find stuff close to your current location. And then in terms of web app geocoding, our web clients such as ArcGIS Map Viewer and apps built with the web app template support interactive and batch geocoding. And these clients, again, will work with the World Geocoding Service or with services that you host on premises or in the cloud.
Okay, thanks, Krista. And I mentioned earlier that while their implementations may look different and different of our apps and SDKs under the covers, the stuff's the same, that we cannot impose that sameness in different SDKs though, because there are naming conventions in Cocoa versus JavaScript and so forth that have to be obeyed. So while the functions and the parameters are the same everywhere, the names of calls and functions will differ between different SDKs. So I picked out a few, or a couple actually, in the REST and JavaScript APIs. Find address candidates does the same thing in REST as address to locations does in the JSAPI environment, and so on down the list. Geocode addresses is the same as addresses to locations, etc., etc., etc. But the good thing here is that having mastered the workflow that you need to implement in one architecture, you can migrate to another, and you'll be familiar with the whole pattern. So that's the good thing about having this sameness and at the deepest level across the engine. So the slide back there mentioned ArcGIS Insights. So I'm going to demonstrate ArcGIS Insights. And And how do I do that? I'm going to go to my home page in my org. And you may not know that you already have ArcGIS Insights as an app that you can use. I didn't really know until just a few weeks ago when I put myself on the self-paced learning. So if I choose out among my home apps there, I've customized my pull-down list to just a few apps that I use frequently, Insights being one of them. So if you don't know Insights at all, it's a powerful data visualization and analysis application. And I'm going to start up a new, what we call workbook. That's the unit of work for Insights. That's where you drag all the data sources that you're interested in mapping and charting and enriching and analyzing. And here we go, it's hydrating a new workbook. Now it takes a second while things behind the scenes get put together. And I'm going to get ready this window here. We're at the mercy of the internet right now, of course. Waiting. Okay, here we go. It woke up. Now I'm invited immediately to add data to the page. So it knows about some of my resources that I own on the portal. It doesn't know about data on disk. I say, okay, Excel or CSV, you can drag and drop it in or browse the computer. I'm just going to drag it in. So it knows about CSV and Excel, that's good. It reads them as tables, and when I look at my workbook, the table is visible, so all's good. Let's have a look to see what's in that data table. Hey, it's people's names and addresses, and it looks like good geocodable data. Now I hasten to add here that these names are fake. They're made up, and the addresses are kind of randomized as well. So nothing about the actual data relates to any actual real people unless it's purely coincidental. So we've got an ID with just an integer, somebody's name, an address, and looks like this data was like a mailing data. So you could print it in 2 lines, base address and city-state zip in the second line, and country is all USA. So that's good. Why don't I just, enable the location for this data? I want to use addresses to enable it. I use the World Geocoding Service. Now I've got the choice of using one field where all the addressing data is, or multiple fields. But I've got an issue here in that the breakdown of the fields that the multiple fields choice wants doesn't agree with my data. I've got 2 fields, so it's neither one or the other. Well, okay, so let's work around that. Let's add a field. Full address, and I'm going to say let's populate that with a function, if I could spell, that lets me specify my 2 fields and get that data in there. So now we're good. So I have what was 2 fields now as 1 field. So I'm free to put it on the map, but I've got a little bit more rows there than I want to deal with for the purposes of this demo. So let's do another powerful little thing, which is easy in Insights, which is filter. And I kind of know the geography I'm interested in. It's one city in Massachusetts, and see the row count at the bottom right here of my table is now reduced to all the rows, or only the rows which relate to that city I'm interested in. And my scenario here, which I forgot to enunciate, is that we've got this population table of thousands of people. I'm interested in doing some target marketing or something like this in this locality. I want to discover what's known about these people at this place, and I'm using geocoding to get my organizational data onto the map here and in a form which is going to help me do my job. So now we can enable location by address. We're in the US, we're going to have 1 field, and it's going to be full address, and we say run. So I no longer need to look at the table because I've got the goodness out of it that I want. I'm going to put it in a new map on the screen here. So that's my data here. I can click on one row and I can see it's these people's names, whoever it happens to be. that's where they live. I got my population data on the map. So far so good. Now what I want to do really is know the kind of demographic profile of these people I got on the map so easily. I'm going to enrich this data, and this is the kind of thing we pointed to with our pyramid graphic. I'm going to enrich this data, and I'm going to say, well, what have we got? Let's open the data browser, and we're going to see what is offered and see how many countries there are. And we keep on going. In the United States, we offer all these things we can enrich the data with. And I don't pretend to know what this all boils down to or breaks down to, but it's a lot. I do know that the tapestry stuff is for the classic market segmentation use case that Krista mentioned in one of the slides. So I'm going to we're going to add this popular variable here, dominant tapestry segment name. So this kind of gives you a thumbnail of the lifestyle enjoyed by the people at those locations. So my 55 odd people there are known to me now. We know a lot more about them. Let's go over here, and we won't style by address. We'll style by the segment name that we just gave these people. Okay, so there's different colors. You can see there's some patterns emerging here. It's a little bit hard to see, so we'll just bump it up in size. Much better. So now here I can see that, let's expand this thing here. Green acres, I'm just making this up, but say green acres might be people who have a kind of lifestyle property size. In studies might be fashion shoppers, and rural resort dwellers are over here. It's kind of some kind of pattern you can see. But if it was real data, I mean, I've just achieved basically the whole aim of my analysis. I took a spreadsheet, I turned it into something I can action. And like I said, you may not know you have insights available to you now. All you have to do is have credits and online, and you can go. You're ready to go. So that was kind of a stub of a workflow which is easily enabled through geocoding and will work worldwide. You have to research the things that Krista and I don't really know about, like what you can enrich with, but that's just a little exercise in reading some of the help. So I find insights not just powerful, but also enjoyable to work with. Things are just easy. Okay, so we're going to share the topic of what's new in the world service. I think I'll talk to quality factors here. Now, we always say we're improving, performance and blah, 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 everything. But this time, it's true. Not that it isn't always, but we added a few things here which are worth talking about. When you use one of the search engines in a browser, if you type in an address that doesn't really exist, but it almost does because the street address range goes to, say, 1,000, but you typed in 1,020, it'll give you a free pass. It's like the thing they do in golf where they let you take the putt without making the stroke. We now do that too. So we'll go a percentage beyond the known address range for a street and let you take that as a match. We will flag that record that we matched it to a street address extension, so you don't lose sight of the fact that that's what happened. There are various implementations of nearness where you say you gave a city, which is not strictly correct for the point that we matched to, but this next neighbouring city is the one that you gave and it's very close, we'll give you that one too. And the same applies for postcodes where they're in geographic areas. So if you applied something that's strictly wrong, but really a person would think that it was okay, then we do the same thing for you there too. And aliasing is another situation. You can type in various forms of street types, for example, and they're just handled for you. You don't have to think about it. Now, the top right there's some red characters. That's basically junk that crept into addresses that were stored in your, or this fictional user's system of record. The way we like to handle addresses is to view them as a whole. And we look at the address and we find a path through the reference data that is best described by what you input. Those red things there are detours from the path. So we'll let you take detours so long as we can get back on the path. And once you've got back on the path and there's enough of the path to have confidence that it's an address, then we know what we couldn't use is junk and we give it back to you in its own field. So there's many kind of cases where this happens. There's people's names, little parenthetical remarks, descriptions of what to do when you get to a place, like, mind the dog, that kind of stuff, whatever it is. If it's not part of the address, we'll tolerate it and we'll flag it and give it back to you and say, hey, we didn't use this. So that's noise rejection capability. Category filtering goes back to the idea of equality of a match. Rooftop, perfect. Interpolation along the street segment, pretty good. When you're falling back to things which are street address extensions, and we don't use the house number at all, we're just matching to the street name, those are different categories of address, match. And there are many that apply to points of interest. There's categories to do with restaurants. You might not ever want to geocode a restaurant, you might be only looking for airports and so forth. So the filtering by category is a way to impose the quality level and specific type of match that you want in your business to your geocoding work. And spatial filtering, Krista knows more about that than I do. So
some spatial filtering is available on geocoding services. If you're working from a REST endpoint, you can pass extents or a specific location and then prefer things within a certain distance of that location. Some new functionality with the ArcGIS online World Geocoding Service in these most recent releases is that we now support locator views, meaning that you can apply a category filter like what Bruce talked about, or some of these spatial filters directly to the World Service and find things only within that are only within those filters that you specified. So you can put, say, a country or an extent filter on the World Geocoding Service itself, and if you geocode against it with tables or interactively, then you'll only find results that are within that filter that you've applied. So,
great. So more things that are noteworthy and what's new. We now support intersections when we're doing the suggestions thing. So for this address in Ireland, this gentleman gave us, if we were looking for the intersection of two streets in Ireland, then we give those in the form with the ampersand character or the word and in between the street names, and any matching intersections that are available will be presented to you as candidates. And new again is we validate any house number that you put in. So if you give a house number that's wrong, we will never let you match to a wrong house number. That's impossible to get right. Street address extension is probably right, but if you supply a house number that is patently wrong, like 1,000,000 or something like that, then we'll never let that be accepted and become part of the geocode returned. Nearby zones, I think we've talked about now. World geocoding, if this, depending on whether or not you're from these places, this may be interesting to you. There's a laundry list of some countries there and part of the USA, DC, that's been ingested now into our services. New data for New Zealand is coming. The graphic there at the bottom there shows an example of suggestions supporting intersections. There's a corner just opposite, straight outside our office at work. Okay, so specifically talking about what's new in terms of much richer demonstrations, there's a session on Thursday in room 17A, do go. And then there's this link here which you can navigate to, take a picture now, and research and keep apprised of what we're doing release after release every few months so you can see what's happening.
Someone was trying to take a picture.
Oh, sorry. Okay, all good. Okay, so another laundry list, best practices. So the good news is we've pretty much automated out all these things that we used to recommend you do. So with our previous generation of technology and you're doing large batch geocoding, we'd say hey, you should sort your data on the zone fields because of the way that the engine worked at that time. You no longer need to do that. I mentioned that we like to look at an address as this whole thing. So it does give you some benefits in terms of quality that you supply addresses as single line input. Don't hang on that you need to do that, but when you supply data as multiple field inputs, we're only going to look one or two steps above or below the input for whether or not it really was a city when it turned out it was a street name. So you can, through bad data entry and bad data capture, hamstring yourselves when really if you just concatenated the data for purposes of geocoding, you'll get a better result. You don't need to cleanse or scrub your data. As you you heard us point out, if there's junk in there, we will kick it out anyway. So you don't have to do that before you geocode. And the last good tip there, don't mix languages. So if you're living in a country where there's more than one language spoken, use just one language for each one address. You can mix languages within a table, but not within a single address. So if you're in Belgium, you have Flemish, French, English, for example, or Switzerland, they've got 4 or 5 languages. It doesn't matter that the languages are mixed in the table, row between row, or within a row, within an address, it will hurt the quality. We're often asked, hey, do you have a standardization function in your geocoding engine? It's simply a feature of geocoding. So it's no longer a product. We had a standardized addresses geoprocessing tool. It's still there, you can use it, but why not just geocode? Then you get the XY as well. If all you're looking for is the standardization, you can throw away the XY, but hey, you're going to get the best result if you do geocode and take your standardization from the result. All the elements of the address which we use to make the match are returned to you individually in the geocode output. The street name, the house number, street prefix, suffix directions, city, state, zip, and so forth. They're all there. Okay, you heard us talk about rejected output is given back to you. So if it's not understood in the address part, you'll get it back. And then things we didn't really show because you should expect them anyway. If there's misspellings, that's not so bad. We won't penalise you. Imagine the call centre situation where somebody's on the phone, they're listening to somebody and they're keying in an address as they heard it. Of course you're going to get Ks instead of CH and so forth. So there's all these common mistakes. That natural behaviour of people is understood by our engine and we will correct for it. Same goes for abbreviations. ST, STREET, and hundreds of other cases for places in the world where it's very common. They use, we call them the dead hero situation. Not to cast aspersions on these people, but there's famous people whose names end up in addresses and they have all sorts of abbreviations, especially for military rank and honorifics and all the rest of it goes on. And lastly, if we know about historic names for street names, they change over time. Cities change the names of streets. We often know what the old name was and we'll let you use that too. So a raft of things that we've engineered to be best practice in our engine. You don't have to do any clerical work to look them up. You don't have to do any cleansing, parsing, scrubbing, all that stuff. Just let us do it for you. Okay, so I think we've covered some points there. We have global coverage. Then it was a new find for me that there's 400 plus combinations of language and geography. I did that little exercise the other day for the purposes of this slide deck. It was pretty impressive, I thought. We've taken a lot of care to give you or use the most accurate data we can for every geography. We maintain that. We let you deploy securely if you need to, on-premise, behind your own firewall, or you can use one of our services. You can profile our service to make them flexible. So that's a secure and flexible way out. We talk about located views as another presentation, which we'll get to in a second. We're referencing it, which you can go and learn all about that. Local languages, of course, are a given, and the cultural expression of languages, as they are in every geography, are honoured. Okay, so this slide is everything that's happening this week in terms of geocoding. This one here now was given at 8:30 this morning, and it's the one at the top of the list, and this is the second presentation of that one. But the rest of them are going on. If you missed the first few there, you're kind of done for Tuesday, but there's a whole bunch Wednesday and Thursday. So that's where you can go to learn more. There's also a showcase, of course, where I think I mentioned the whole team are down there all week. Do go down, dig into any kind of specific issue you have. And
and if you would not mind taking the survey on the app, it just takes a couple minutes and it really helps us plan our presentations for the future so that we give you guys the best experience possible. If you open the Esri Events app and navigate to this session in your schedule, at the bottom there's a link to the survey. It's just like 5 things that you give a numerical rating and then a space for comments. And if you could tell us what we spent too much time on that you already knew, or what we missed that you really wanted to know about, that's very helpful for us in planning for future user conferences, and maybe we'll add it in next year so that you don't miss out too much.
I'll just leave this one up so you can have a look at it. But we got our 15 minutes that we wanted for questions, so we're all good. So anybody, shoot. Sir. Is that Ordnance Survey? I know it's expensive. I don't know if any agreement has been reached about making it financially feasible to include. That's as much as I know. We certainly are familiar with the data. If you need to track what is happening with that, take my card and we can do that later on after the show. Not today, but next week onwards. I didn't paraphrase that question, sorry. I'm supposed to repeat them. Gentleman here from the UK knows about a data set that's available in his geography. Are we using it? Because it is the definitive address list. And the answer right now is not right now, but it may happen.
Does the World Geocoder take into account things like the sub-address type and sub-address value, like apartment 1 or suite?
The question is, does the World Geocoder take into account sub-address details like apartment numbers and so forth? The answer is yes, if we have the data. The engine understands floor, building, suite,
all kinds of unit numbers. If the data. So in countries where we had that dark brown coverage, it's more likely to be available, but we're dependent on where that data is available and what we get from our data vendors on that. So we do also, if you're building your own lake locator and you have that data, we do have a style that supports that addressing style with unit numbers. And you can build your own to support that use case as well.
We have new technology rolling out through the second half of this year, an early adopter program for it, and part of that is a better outcome for kind of sub-addressing. So if you want to engage with us and become an early adopter, get the tool that we're building ahead of time, then you'll understand what's coming and be able to deploy it. Thank you.
Just along those lines with the unit, I work for the city of San Francisco, and we're embarking on a project where we're mapping out the units of all the addresses. So we have all the addresses, but maybe half the units we want to populate it all. So if we were to contribute that kind of data, that could be useful in your common. What kind of licensing? Is that open source data? Is that data available to everybody who has the license for it?
Well, and so the question was, a gentleman curates data that includes sub-address details for San Francisco, was it? And you're interested in how it would be licensed between yourselves and ourselves if we were to include the data? I don't know the answer, but certainly I should get that website up so that we get that known, so you can take a picture of it. Let me find out where that is. It's not here, is it?
No, it's up. Further. Up.
Oh, yeah. Good.
Up.
Wow, way up. Okay.
Yeah,
here it is.
That
here.
one.
Skip verification. So take a picture of this site here, this URL. Living Atlas, so go down here. So there's a link that you can get to this landing page and jump in there and start a discussion with us about how it will be licensed. I'd say we would be interested in address points where you've captured the sub-address information. If you can share, we'd be interested. How it works out in contracts, I don't know the answer.
Any other questions? Sure.
Who are your data vendors for US?
So we have, is everybody done looking at this URL? We do have a site on our ArcGIS online documentation that lists our data vendors for every country. So you'll recognize this map that we used in the demo showing our coverage, and then for every country that we have coverage for, we have this information available here with the country name, the country codes, the languages that are supported, and then the data sources for that as well. So level 1 is our top level coverage, and we have these countries. If we go down to the United States, we use the opendata.dc.gov here, and GeoNames are our primary data sources. And you can find that for any other country that you're interested in geocoding in and review the data sources that we have to see if it fits your needs. Any other questions? Okay, go have dinner.
Thank you very much.
Thank you so much.